So it would be on. Yep, it would be on because there is current going through it, but it's not neither net in saturation or in cutoff. So it would be on because there is current going through it. Yeah.
Just looking. Okay.
All right, let's take a look at. So let's look at open RV there. Or open
BBB?
BBB, thank you. Open BBB, I can't remember what the... Okay, so if I had open BBB, meaning that my source isn't hooked up to my my base, what would I measure for voltage then for BBB? Zero. So that one. So I hope we should jump. Let's see. We kind of jumped down right away. Jumped down one, but yeah, that would go down to 0. So that one would go down. Let's just jump back up again. So what's gonna happen to my DCC? What's gonna happen with that one?
Stay the same.
Stay the same. That one's not gonna. Nothing's gonna change there. Then my voltage of my base. What's that gonna do?
0 volt.
0 volt.
0 volts. So remember, always gonna draw your base, collector, emitter. So that's gonna drop down to 0 volts. So that one will decrease. How about my voltage of my emitter? So now I'm right here, measuring from here to here.
0.
0. Yep. So that one's going to go down. Yep. If I don't have any voltage on my base on this particular circuit, then I'm not going to have any voltage on my emitter. Then the voltage across RE. Then what's that going to do?
0.
0. Same. Different way of asking it, but it's the same thing. Then my current going through my emitter,
0.
0, so that's going to go down, so that's just an arrow down. Current going through my LED, 0. Voltage across my LED, 0. Voltage of my collector, so now
0.
So right here, right? So what would be the theoretically what would I?
Source voltage, theoretically.
Theoretically, I would maybe kind of say my source voltage, or theoretically, I would still say 0 actually, because right, we're going to treat that LED as an open.
Right, yes.
Yep. So this one theoretically, this one would be a 0, but the minute I put my voltmeter in there, I'm probably going to start measuring some voltage across that, because I'm going to activate that LED. So theoretically 0, practical, we'll probably measure something. And then, would my LED be turned on?
No.
No. Don't have any current going through there, so I don't have an LED turned on. Is Q1 turned on or off? Off. And it's totally off. It's in cutoff. There's no current going through there, so it's in total cutoff. All right, any questions on open BBB then? That one's pretty straightforward. All right, so open CDE. This one's a little tricky. So open CDE, so we can just kind of assume, here's our, I'm going to circle my whole device, here's my whole transistor here. And what it's saying is that internally inside that transistor is that there's a broken wire inside there, or burnt out or something like that. So it gives me an open from CDE. In my lab, I can just go ahead and I can just pull your lead off your collector. Yeah, just pull off your lead coming from your LED down to your collector and just remove that, and that'll simulate your CDE. So if I have an open CDE then, collector to emitter, what's going to happen to my DCC? So here's my DCC. What's going to happen to my voltage of DCC? Increase, decrease, or stay the same? Stay the same. I'm still going to have my source voltage. Yep. Didn't do anything to my source voltage. And how about my voltage of my BBB?
Same.
That stays the same. Nothing changed there. Still going to get my plus 5 volts. And how about my voltage of my base?
Stay the same.
That one's going to stay the same. Still going to get my 5 volts. How about my voltage across from my emitter to ground, my DE?
Same.
Stays the same. Still going to drop my 4.3 volts. Even though I have something internally in there for my collector emitter, my base to emitter is still good. So my base to emitter is still good. So I'm still going to get the 4.3 volts drop across there.
And the 0.7.
So we're on B, and then, so what's my voltage across RE? Is that going to increase, decrease, or stay the same?
Stay the same.
That one's going to stay the same. Then my current going through, IE.
Stay the same.
No, it doesn't. Does it?
Yeah, does it?
Yeah, it does.
So,
Oh, yeah, it would, because RE is the one that determines the.
yeah, typically my current going through RE, what actually ends up happening in reality is that I have just a very small amount of base current going through here, because the majority of my current is going through here, right? So most of my current on the real circuit, I'm going to have 13.03 milliamps of current going through here. 13.03 milliamps is going to go through my collector, so how much would be the remainder going on across my good circuit? How much current would I have going through my base? Practically 0, right? Because all my current should be going up through here. But now, all of a sudden, if I don't have any current going through here, we said that this voltage is going to stay the same, this current's going to stay the same, so now where's my current going to have to go?
All the way back to
It's going to have to go right back to the base. But the minute I hook my collector back up there, then the majority of the current is going to go to my emitter to the collector. That current's going to have to go somewhere because we turned on that transistor from our base to emitter. That took its 0.7 volts. I got the voltage going across my resistor. I got the current going through there, and it has to go somewhere. So now it's all of a sudden it's going to go back, and it's going to. Then what's going to happen is that this thing is going to drop. The impedance of this thing is now I got 13.03 milliamps of current going on my base now. That means I'm really loading this circuit down. My input resistance going into this thing is very small. It's going to be less than 330 ohms, or approximately 330 ohms. When this circuit's working normally, it's actually way up there in the mega ohms. Okay, but now all of a sudden this transistor failed, the input impedance of this thing dropped, the current started to increase across my base, and whatever this device is that it was trying to drive, we probably just burnt off this device because it couldn't handle that amount of current going through there. Remember, that's what we're trying to do, is protect this output device here, because we want a very, very small amount of current going into it with a very high input impedance. The minute that transistor burns out, I probably end up burnt out this one too. So what happens is that, so I'm coming in, and we'll just say some digital chip or something, I don't care what it is, but this is kind of our V out of this one. It can't handle much current. All of a sudden that transistor burns out, it starts driving a lot of current, then this one starts smoking. So this one also becomes an obvious one. We see this that this is the one that smoked, that's the one that cooked. So so we look at our board, we see this physical component, it's burnt up, it's fried, it's smoked, we can see it. So what we do is go, hey, I can fix this in about 2 seconds. So I go ahead and I take this component, I replace it, I pop it back in there, I hit my power switch, and what happens? Boom, it smokes again. Typically the device that fails is not the cause of it. A lot of times it's from something else down the road. So you have to be careful about when you're doing your troubleshooting. Don't replace the ones that smoked. Look for the additional problems that caused it. This one might not show any visible sign. That one just opened up. That could have been anything. It could have been a bad solder joint. It could have been something internal in that transistor. We don't know. It might not have any physical evidence that it burnt up. Just because this one opened up, most likely this one isn't going to be burnt up because it just hasn't opened. We didn't get a lot of large amounts of current going through this thing. This one here got a lot of current, so that's why that one smoked. This one probably never did smoke because it never got the current. It's the current that's going to kill these devices, and that's what's going to smoke them. So be careful about replacing the component that's burnt up. That's typically not the culprit.
So the current would stay the same in RE, it's just the impedance would drop?
Yep, and the impedance would drop. The input impedance would drop of it. Yep. Yep. Typically, if we're looking at it going into the transistor, if I'm viewing in, looking at it this way, when this circuit's working, it's going to be up in the mega ohms. Very small amount. But the minute that thing burns out, now it dropped down to the 330 ohms. Yeah. Yeah. Because when that thing's working, most of my current, majority of my current is going up to my collector. All right, good. Good job on that one. I don't think I've had anyone identify that one before. All right. So let's see. We were on current of IE. So then the current of the LED. What happens to the current of the LED?
Zero.
Zero. That one drops. The voltage of the LED.
Stay the same.
Well, if we have a path to ground, with that voltage of that LED, if I have an open here, right? So this is going to measure all my source voltage, right? So how much voltage is left out of my LED?
There's an open LED, so I figured the LED is open itself.
No, we're still on an open collector to emitter yet.
Oh, I'm sorry.
Yep, we're still on the same column yet. Yep, you moved over one column.
Yeah, I'll
you're working the edge there, Bob, yeah.
So
Stay with us, Bob.
Yeah. So the LED would drop to zero?
Yep, because the collector to the emitter, that's an open, right? So that's going to drop the source voltage.
Yeah, but the collector to the base is the path, the base to the emitter is the path.
You mean from here to here?
Well,
The collector to the base?
You can't work around that open? From
No.
70 to 80?
Nope. If we take a look at it, so if we treat this collector to the base, if we treat that as an open, to do our soft voltages, what's my soft voltage on my base here? Would be a positive 5 volts, right?
Yeah.
Okay. What's my soft voltage on my collector?
If it's an open?
Yeah. Just to say for approximation, with that LED it makes it tough, but let's just say it's a positive 15 volts, okay?
Yeah.
So we have an NPN, right? So here's NPN, right? So we know that to get this junction from our base to our collector, this would have to be more positive than our collector, right?
Oh, okay, I got it.
But since we're not more positive than
Yeah.
that's why that one always is actually an open. Yep, because we're never more positive than what our collector is. Yep, so that one just treats like an open. Yep. Alright, so then then what's going to happen to our DC? Assuming that our open is inside the transistor, what's going to happen to my voltage of DC? Like an increase, decrease, or stay the same? Increase. That's going to be measuring across the open.
So the LED went down.
Yep, LED went down. That's turned off. Yep. There's no current going through it. There's no voltage across it, and it's turned off. So yeah, so the LED is turned off. And is my transistor turned off or on or off? Off. There's no current going from my collector to the emitter, so we would consider that an off. Even though I still have current going from my base to emitter, my collector to emitter, there's no current going through there, so that would be considered off. All right. Now we can jump to Bob's been dying to do the open LED, so let's jump on that
I'm
one.
not dying to do it.
Alright, so let's get rid of this. So this time there's no LED in there. Okay, so my VCC, what's that going to do?
Stay the same.
Stay the same. BBB,
Stay the same.
stay the same. BB,
Stay the same.
stay the same. BE,
Stay the same.
stay the same. BRE,
Stay the same.
stays the same. IE,
Stay the same.
stays the same. Current of LED,
0.
0, so that goes down. Voltage of LED,
2 volts.
theoretically or practical. So if I send them there to measure my voltage across my LED, right? Okay. So if I measure across my LED, now I'm putting in my voltmeter, and it's got 10 mega ohms of resistance, right? What is going to be that voltage across that LED? Is it still going to stay 2 volts?
No, it'll change.
It's going to change, and we don't know what it's going to change to because CDE, we're going to actually have current going through there. It's going to come up through my emitter, going through my voltage power supply or my voltage meter, and come back in. But this thing here is going to have 10 mega ohms of resistance it's going to try driving it at 13.03 milliamps. It probably won't get there because 10 mega ohms is so large, but it will drop a little bit of it will drop majority of the voltage because it's going to try bringing that thing down to 0.2 volts. So most likely, if I was going to measure the voltage across it, I'm going to get my 15 volts minus my 2 volts that LED or that transistor is trying to drive. Yeah. So so my voltage across the LED is going to do what? Go up, increase, decrease, or stay the same? It's going to go up. It's going to measure up to 14.8 volts when I put the voltmeter on there. Yeah. Little kind of gray area, a little tough one there to figure out, but. All right, then my voltage of my collector, what's that going to do?
Go down to 0.
Go down to 0. Is the LED on? No, not even in the circuit. Is Q1 on? Or Q2 on?
Yes.
Do I have any current going with that LED being open? Do I have any current going through the emitter to the collector? No, so it's not, nope, would be considered on. Nope, it would be turned off.
Base is forward bias, it'd still be off.
Yeah. So. Yeah, so you gotta be careful about putting in your voltmeters and stuff like that, and kind of think through it what's actually really happening. So. All right, so well, we got 45 minutes. We can either spend the rest of the time either in lab, or you can there's much time for labs. You don't get yourself set up, but you can start your lab view if you wanted to. Otherwise, there is one more circuit there that you can go over if you wanted to go over one more complete circuit, but it was kind of very similar to what we did the other day. But if you need more help with transistors, I can spend more time on them. Check out okay on yours then. All right. Yeah, if you want to, otherwise I will do a comparison to see, but if you want to just, it doesn't take